Hi, today my name is Chuan Khang Wei.
My name is Shen HIen.
Okay, with my metric number is 185138.
My metric number is 185900.
Okay, today we are going to give explanation for our assignment regarding vector integral calculus. And now Tan will explain about question 1.
So now we look at the question. Question 1 is about for region D of boundary C, analyze the line integral of the equation, and we can do it by two methods. The first method is directly by parameterizing the path C, or using the second method is by applying Green's theorem. Now we look at the solution. Okay, now I'd like to explain using the first method, which is directly parameterizing the path C. Okay, so what I do is I break into three paths, which is from here to here and here to here and here to here. So you can look at this equation. These three equations actually I integrated the three paths and I added together, which you can see this part is from x 0 to 1, and this part is y from 0 to 1, and this part is from 1 to 0. Yeah, so like we can look at the first equation where the y is 0 and the dy is also equals to 0. So when you substitute it inside it, you get x3 dx. And the second path where x equals to 1, dx equals to 0, and when you substitute it, it become equation -1 y squared dy. And come to the third equation where the line y equals to x, and when you integrate it, dy equals to dx. So when you substitute it into the equation, you get x3 dx minus x squared dx. So from here you can proceed with the integration, and we get x to the power 4 over 4 plus negative y power 3 over 3. So you get 1 over 4 minus 1 over 3 plus 0. So at the end, the answer will be -1 over 12. Now come to the second method, which is Green's theorem. Green's theorem stated that integration of p dx plus q dy would be equals to double integration of dq over dx minus dp over dy dx dy. So firstly, we have to determine the limits of x and y, where c equals to 0, d equals to 1. And if you look at the g2y and g1y, how to determine it? Because if you look at the graph, the limit of x for this graph is from 1 to y, where x equals to 1 and x equals to y. So now you can look at this equation. When you substitute everything inside, you get equation like this, where you have to differentiate with respect to x first, the negative y whole square, and you will get negative y square x, and you differentiate once again, and you will get negative y square minus y power 3. So, and you integrate with respect to y, and we get something like this, where negative y power 3 over 3 plus y power 4 over 4, and you get -1 over 3 plus 1 over 4, and the answer would be -1 over 12, which is exactly the same as the answer using the first method. Yeah, that's all from the question 1. Now Chuan would like to explain about question 2.
Okay, so basically for the question number 2, it asks us to analyze the following integral of a system. So this is a question with the condition given is when the region bounded by the plane x equals 0, y equals 0, z equals 0, and x plus y plus z equals to 1. So the solution would be, okay, So as you can see, there's actually 3 parts of integral. Okay, so it will be break down into this 1/4 with respect to x. Okay, 1/4 is the constant, we bring it out, and then with the respect to dx, respect to dy, and respect to dz. And then how do we find the the limit for these 3 parts of integral? It's from the condition given, which is when z equals to 0, when z is equals to 1 minus x minus y, and then when y, it will be equal 1 minus x, and when it is x, x will equals to 1, because it will be both x and y and z equals 0. And then okay, next we will start integrate the z part. Okay, so as you can see, we integrate the z, and then we will get this form. Okay, so after we get z, then we will multiply the z into the y integral, which you can see here. It is now become y times 1 minus x minus y square over 2. Okay, so for now, if we integrate this, it will be if we expand it, it will be very complex. Thus we use a method called integration by substitution. So the method will be, let u, which is u equals to 1 minus x minus y, which is the inner part of this. Then let y, we bring the y in front, equals to 1 minus x minus u. So when we differentiate u in respect to y, we will get -1. Thus du equals to dy, and at the same time dy also equals to -du. So we will substitute into the formula in the previous here. So when we substitute dy with dy with -du, and we substitute y with 1 minus x minus u, and we substitute 1 minus x minus y equals to u. Okay, so as you can see, we already bring the negative of du into the constant 1/4. So we bring it in front, then we expand it, we will get this form. So from here we can now integrate the u part into then we will get this form. Okay, u power of 3 over 6 minus u power of 3x over 6 minus u power of 4 over 8. Okay, so after we expanded to this part, then we can substitute back the u equals to 1 minus x minus y, because now we need to put the limit 0 and 1 minus x into the value of y. So as you can see, when we substitute back the u, okay, it will be this form. Then we will do the integration, and at the last we will get this answer. So then now we already get this. So like just from the previous part, we will substitute the answer from the integration in respect to y into x. So now when we multiply it, it will be okay. So we continue. So from here, at this just normal expansion, so 1 minus x cubed, so we expanded this form, and then at last, after that all the long expansion, we already actually skipped it to this, we will get this answer. And then as the same, so we integrate with the limit x equals x0 to 1. So the final answer will get, the expansion will get -1 over 2520, and then we multiply with -1 over 4, and at the last answer will be 1 over 10080. Then we convert to decimal, it will be 9.92 with the exponential of -5. That's all from our explanation. Thank you.